I'm going to give you an update of AP1000 construction in China. There's quite a lot going on over there, and for all sorts of reasons, as you can understand, it's really important in terms of how those early plants are going in China, the experience there, and what that tells us about future AP1000 projects. First of all, in the US, and then beyond that, when we come to build them in the UK. A little bit about Westinghouse, and forgive me, many of you will be, I'm sure, familiar with what we do. We are purely a nuclear company, so unlike Areva, we've decided to focus very specifically on the thing that we think we are strongest at, which is nuclear. We have three main parts of our business. The nuclear power plants business, which is the bit I'm going to be talking about today, but we mustn't forget the nuclear fuel side and also the nuclear services business, both of which tends to follow the new plants business. So a lot of the fuel business that we have and a lot of the services business that we have all the way around the world is on reactors which are Westinghouse designed plants. So the three businesses very, very closely linked. And we are active in all of those three sectors in the UK. Fuel at Springfields, which I'll say a little bit more about in a second, and also our services business. We've done quite a bit of services work on the AGR fleet and on Sizewell over the years, and we're now part of a decommissioning consortium up in West Cumbria, Cumbria Nuclear Solutions Limited, bidding for work up there on some of the decommissioning contracts on Sellafield site. To say a little bit more about what we do in the UK, just about an hour's drive from here at Springfields, up near Preston. It's the UK's nuclear fuel factory. Basically, we make almost all of the UK's nuclear fuel from that site, and that's provided fuel for every one of the UK's nuclear power stations going back more than 50 years. We've made, as you can see, over 10 million fuel rods of one sort or another over that time and avoided over 1 billion tonnes of carbon dioxide emissions. And we employ around 1,600 people on that site, directly or indirectly. And as you've heard before, Sizewell B, the last reactor to be built here in the UK, was a Westinghouse design as well. But I'm not going to talk about Sizewell today. We've heard about that in great detail from Greg and about some of the lessons we can learn. I'm going to talk about this one, the AP1000, which is our reactor that we're now marketing around the world as the standard Westinghouse product. And it's worth bearing in mind, just before I go into any of the technical detail and start to talk about China, what an AP1000 can do. I see a lot of the press cuttings from the energy sector, and I keep hearing stories about a new wind farm or a new biomass plant or whatever that's going to power X thousand homes. So I recently did the calculation for how many homes in the UK an AP1000 would power, and it's about 2 million. That's a heck of a lot of homes, providing electricity, clean, reliable, affordable electricity to 2 million homes day in, day out. Looking at the actual technology and the fundamentals of the reactor itself, and I'm not going to go through all of this in great detail. There's a chart up there that just shows you the different parts of the building and the layout. Probably two things to talk about in terms of what makes an AP1000 different from some of the other designs that are available. One is the passive safety approach that we have to keeping the reactor safe under all conditions, and that relies on things like gravity, natural circulation, evaporation, condensation and so on, natural phenomena, as a key part of the safety case to make sure that the reactor always reaches a safe condition. And that means that the amount of material and the other active safety systems that we need to put in there to make that safety case can be dramatically reduced. So, and this is specifically for Chris's benefit, because Chris always likes to accuse me of stealing the food from the mouths of valve makers' children. The fact that we have 50% fewer valves in the AP1000 than a conventional design, and similar proportions of pumps, pipework, cabling, seismic building volume. And I think I'm going to get this revised as well to say we've got 100% less cardboard than Sizewell B had in terms of the need for making the mock-ups prior to construction. So passive safety is one very different feature of the AP1000 design, and the other one, which was alluded to earlier on, is the modular approach to construction. We do a lot of the manufacture of the AP1000 off-site, preparing large modules, and you'll see some pictures of some of those modules later on in the presentation. They can be anything from the size of a large desk to a 6-storey building. Doing that manufacture and sub-assembly off-site, then bringing them to site and assembling the modules together, a little bit like nuclear Lego. And that allows us to do a number of things. First of all, it allows us to make the modules in a high-quality, high-spec, controllable factory-type environment. And it also keeps the number of on-site construction workers lower than for comparable designs. So you will still have a large construction workforce on site, particularly pouring concrete and doing the early earthworks and so on. But some of those concerns of the local stakeholders of are they going to have 5,000 Polish construction workers living in Chemnitz for 5 years can be alleviated by the fact that a lot of that work can be taken away from the site itself. Moving on now to talk about China, I just wanted to set the scene with a couple of slides and talk about China's demand for electricity. I mean, for those of you not familiar with China, and probably aren't many of you in the room who aren't aware of some of these facts and figures, they are quite astonishing. And a demand for electricity that is growing at 13% per year. When you ratchet that up and work out just how many new plants that means they need to build over the next 10 years, 15 years, 20 years, of all sorts, just to keep up with that demand. And that electricity demand is inextricably linked to their economic growth. So without that electricity to supply that their industry, all of their economic aspirations are at risk. Their electricity consumption already is the second highest in the world, and it's in danger of becoming the highest very soon with that huge rate that I talked about, the rate of growth. And they're adding capacity, as you can see at the moment, 800 gigawatts to 1,400 gigawatts by 2020. It's absolutely astonishing growth when you think about how that compares with pretty much any other market in the world, and even combining some of the other big markets in the world. They're looking to achieve 70 gigawatts of nuclear by 2020 and possibly as much as 200 by 2030. And you could have a whole global nuclear industry just serving China, and there would be plenty of business there if they keep to those goals. That will certainly make China the biggest generator of nuclear in the world if they get anywhere close to those aspirations. And obviously new build is underway there in China as well. You've heard a little bit about the two Areva plants that are being built. There are actually more than 20 plants under construction in China. Most of them are of older designs which are not being marketed in the West. So the two that we tend to hear about are the EPR projects and the AP1000 projects. And in addition to those 20, there's another 27 at the moment in the planning stage. They're already talking to us about the next 10 AP1000s that will come after the 4 that we're currently building for them. And the AP1000, as I said, is their technology of choice. It's the design that they selected first as their Generation 3 Plus programme, and as well as the contract for 4 that we won back at the very end of 2006. As I say, they're now talking to us about many more. Just a little bit of the geography for you. 4 units across 2 sites. The lead site is Sanmen, over here just south of Shanghai. The second site, Haiyang, to the north, both of them on the coast. Haiyang closer to Beijing. The first unit at Sanmen will come into operation in late 2013. The second unit will be at Haiyang, then the third will be back at Sanmen, and the fourth will be back at Haiyang. And you can see some of the key dates for both Sanmen and Haiyang there up on the chart. So by the time we get to 2015, we'll have all 4 of them in commercial operation. And the consortium that's actually building those plants in China is Westinghouse and the Shaw Group. So the 2 of us working in partnership to deliver those AP1000 projects to China. This is interesting. This is, I suppose, the 21st century equivalent of the cardboard model to show you how it will look when it's finished. But the Chinese don't mess about. This is actually a mock-up of the Haiyang site, where we've got 2 units under contract at the moment. But their artist impression, they didn't bother stopping at 2. They've actually put all 6 of the possible AP1000 units on their artist's impression that they show out to visitors, and the same is true of their mock-ups of the Sanmen site. So both of those sites have the capacity to build a total of 6 AP1000s in the fullness of time. And as I say, we're already talking to them about the follow-on units. And again, when we just look at some of the detail and the background of this site mock-up a minute, and you'll see some of the compare and contrast with some of the things that Greg was talking about the need to keep local stakeholders engaged and involved. At the sites in China, there aren't key local stakeholders. There are not villages just on the doorstep as you have at Sizewell, or indeed Wilfer and Oldbury and up in West Cumbria, where if you stand at the entrance to the site with the reactors behind you, what you probably see is an old lady pulling her curtains back across the road. In other parts of the world, in particular in China, we don't have that. So take very clearly on the chin the fact that there isn't a lot of local stakeholder management that needs to be done in China. So there are still some lessons that we won't be learning in China that we have to take at the first time when we come country by country. I just wanted to put up the schedule overview for you to show a couple of things. The actual schedule that we plan to is the same for all of the 4 plants. So you've seen some very dramatic evidence from the previous speaker about the lessons learned going from first to second to third to fourth. We've actually planned to deliver all 4 of them on the same time scale. And fingers crossed at the moment, as you'll hear me say probably a number of times during this presentation, we are on schedule or ahead of schedule with all 4 of them. That lead plant, the key one, is on schedule at the moment. So we're actually, I think, just about 20 months in with 30 months to go of that 50-month construction period at Sanmen. That means we'll be loading fuel in 2.5 years' time in May 2013 with a view to bringing that reactor into commercial operation November 2013. And then the following plants very broadly are on a 6-month drumbeat following on from that lead site. So that's a huge challenge in itself to deliver 4 reactors anywhere in the world 6 months apart. Some of the key project milestones. Well, we signed that contract, which includes that schedule. We signed that back in February of 2007, and we've stuck to that schedule. That's not wood, but I'll touch it anyway. Sticking to that schedule up until now, and planning to do so out into the future. You'll see. I won't run through all of these dates. Very importantly, March the 31st, 2009. The picture that's up there, top right, was the first concrete pour at Sanmen. The contract said end of March 2009. We finished pouring the concrete at about 4:30 in the afternoon on the 31st of March 2009. That's a tick in the box. It was a big sigh of relief, but it was a tick in the box. Very interestingly, and just as an aside, and perhaps it shows some of the cultural differences between China and some other countries, we weren't allowed to say that we'd hit that milestone for another 19 days. We as Westinghouse, keeping to that schedule, hitting the first really big construction milestone, it was a huge piece of news for us, as you can imagine. We were itching to tell people. We published the key dates in the schedule, so we had journalists ringing up on 1st of April saying, "You're not poured your concrete yet then?" And all we were able to say was, well, we're keeping to schedule. So they assumed that we'd slipped the schedule. The reason we weren't allowed to say it was because the Chinese, this is such a big, strategically important program for them, they wanted the Vice Premier of China to go in there to cut the ribbon for the ceremony to mark the pouring of the concrete. And in China, you don't send the Vice Premier to announce something that the rest of the world already knows. So for 19 days, until he could fiddle his schedule around between whatever else he was doing, it turned out to be on a Sunday afternoon, I think, I got an email message saying, we can talk about it. And then we were able to say, well, 19 days ago we poured this concrete. But we had an interesting 2.5 weeks up until then of people assuming we were late, which is exceptionally frustrating in the nuclear industry when you're not late and everybody thinks you are. A little bit like snatching defeat from the jaws of victory. So, some challenges, and again, we won't have that in the UK, I'll tell you now. When we've poured that concrete, you'll be the first to know about it. In terms of progress, and again, some key dates. I won't go through all of these because I know the slides will be going on the website afterwards. But you'll see both at Sanmen, this is for the Sanmen site, Units 1 and Unit 2. What you can see on the right there is one of the big modules being lowered in. That module is actually the CAO1 module. That's 1,000 tonnes in a single module. And I'll show you some other pictures of that later on, but it really emphasises modular construction in one picture. And you'll see some dates that we've hit through this year. The second unit, perhaps if I just pick out a couple of them. The CV, where are we? Can't find it now. The closer you stand to the slide, the harder it is to see things. CV bottom head, which I'll talk a little bit more about later, was actually December of the end of last year. That was, in the end, that particular milestone did run about 6 months late. And I'll talk about how we recovered some of that later. So we were 6 months late doing that. The bottom head, which is a huge dome-shaped structure, somebody's called it the biggest wok in China, that sits underneath the first containment vessel ring that you can see there. Hugely challenging to do. And that was about 6 months late when we put it in. So you can see that again, if I can find it, CV bottom head for Unit 2 was only 6 months later, and those plants are actually on a 12-month time lag between the two. We were much slicker and cleverer doing it the second time. In fact, there is a picture of that biggest wok in China, the containment vessel bottom head. This is actually one at Haiyang, but obviously they are identical. And you can see some of the corresponding dates there for the Haiyang build. Unit 2, first concrete, completed in June 2010. Unit 2 at Haiyang is the fourth of the four. That first concrete wasn't poured just like 6 hours ahead of schedule, that was poured 6 weeks ahead of schedule. So you can see by starting off with the same schedule on the 4 plants, as we go from Unit 1 to Unit 2 to Unit 3 to Unit 4, exactly as you heard from Tom, we're getting ahead of cutting down on the schedule, and actually we were 6 weeks ahead of schedule to hit that key milestone of pouring the concrete at Haiyang Unit 2. This is that delay that I mentioned, and it comes back to the issue of modular construction. So you can see the table at the top shows you first concrete, we were on schedule with that. By the time we put the auxiliary building module in, we were running about a month late. By the time we hit the containment vessel bottom head, it was due in June, we did it just before Christmas, we were actually 6 months late. That containment vessel, you'll have seen it on that previous slide, huge thing. It's made in segments, a little bit like orange segments, that have to be bent to shape and then welded together. And that was really, really challenging to do. We learned a lot of lessons on that, but the first time it was really, really tough to do it. So we were 6 months late in getting that in. By the time we got the first ring in on top of it, it was 3 months late, and by the time we put the second ring on top of that, we were back down to, well, it says 0 delta. I'm prepared to take a hit for 3 days or 2 days, but we were pretty much back on schedule. And the reason for that was the modular build, because whilst we were overcoming the challenges on getting that bottom head, the segments of that bent to the right specification and then welded into the final unit, we were still carrying on doing lots and lots of work on those other modules in parallel with that. Separate teams, separate locations, doing all of that work such that when the bottom head goes in, 6 months late, we're then able to put the other modules now completed to schedule, get them installed on top of it and recover that delay. So something that we wouldn't have been able to do with conventional construction approach, by having the modular approach, we were able to recover that. This is a picture just taken a couple of months ago, 4 or 5 months ago now, back in June. Just wanted to show you, you can see in the foreground Unit 1, but you can also see Unit 2 in the background. And it just shows you what a year's worth of activity means. The 2 units, as I said, are about 12 months apart on this one site. So you can see just about in the background there, the containment vessel has probably just gone in for Unit 2. We've got 2 rings on top of it at Unit 1. You can see the turbine hall as well under construction in the foreground, whereas it's pretty much a pit in the ground in the background. So that just shows you quite interestingly and graphically what 12 months of activity can do. And obviously in 12 months' time, that one will be like this, and the first one will be considerably further on again. Just some pictures now, and again, just to this one is that bottom head at the various 3 sites. I really don't know why I put this on, except that it looks like the same one from 3 different angles, doesn't it? Really, and that's the whole benefit of standardised plan. In the UK, I suppose, in our traditional history, we'd have had 3 very different pictures for the same component if we'd been doing this on the Magnox stations. But that just shows you the programme for that. For the auxiliary building, this is one of the first big modules that goes in. The CA20 building. This one is about 800, 900 tonnes in weight, and it's assembled from a whole load of sub-assemblies that are road and rail transported to the site. That can be made some distance away from the site in a factory environment. And you can see the way in which it's constructed from the different sub-modules shows up very visibly on the finished module there. Those sub-modules assembled together close to the site, and then the final module lifted into place. And again, as I say, this one is about 800 tonnes. And this CA01 is actually the largest single module, and this is that 1,000 tonne lift going in back in March of this year. And Greg talked about cranes. You'll see the crane in the background there. That's actually one of the biggest cranes anywhere in the world, and procuring the cranes and getting the cranes booked for projects like this is absolutely a key part of the construction, particularly with the modular design, where some of the craneage requirements are pushing that envelope quite dramatically. This is the latest picture from Sanmen 1, so this is back to the lead plant. This is the 3rd ring of that containment vessel being installed. That's what it looks like if you're standing inside the reactor. You can see that big module that I showed you on the last slide right next to it there, and that's the looking up view to show the handling equipment as well as the ring itself as the ring is lowered onto the reactor. And some pictures of some of the big components. Again, nothing startling in this. They're very similar to what you'd be familiar with in some of those other programs. Not that different from the same components that we saw some pictures of for Sizewell B going back 20-25 years. The one thing I did want to highlight, particularly on this slide at the top right, the reactor coolant pump casings for our units at Sanmen are being made in Sheffield. Sheffield Forge Masters have got the capability to make not the large forgings, sadly, for reasons that we've all heard about in the press, but they do have the capability to make small and medium-sized forgings. It seems strange to call them small and medium-sized. If you ever go there and bash them, they're pretty big lumps of metal made to very tight specification. But Sheffield are one of the best companies in the world at doing that, and we're delighted that we've got a key part of the supply chain for our plants in China is actually based in the UK at Sheffield. And those are being made out there at the moment and shipped out for further testing. The reactor vessel, again, fairly familiar pictures, and you'll see it looks very similar to a conventional, any other reactor pressure vessel. Just wanted to spend the last sort of 5 or so minutes talking about lessons learned, and absolutely a key part of what we're here today to think about. It isn't just learning from the past and plants like Sizewell, and I'd echo Greg's comments about that recent publication that was produced, I think, just last week. There's some really valuable lessons in there that we must, as an industry, learn and have ingrained into our approach to projects of any kind as we go forward in this industry. Going back, looking at not just reactor projects like Sizewell, but they've looked at construction big projects at Sellafield. They've looked at reactor construction projects around the world and some of the key lessons. But looking particularly at what we can learn from the present as well as the past in terms of our build programme for the near future. We've had a very active lessons learned and lessons capturing programme from our AP1000 plants in China, and as well the plants that we're doing site preparation for in the US, although obviously the number of lessons is not quite so great there at this stage. But some of the things that has impacted on directly, the base mats at the later stations where the concrete was poured in much reduced time. Certainly at Haiyang 1, beg your pardon, and Sanmen 2 laid in much less time than Sanmen 1, and the same was true for Haiyang Unit 2, as I said. The lead times for some of the forgings have been significantly reduced as well. The module fabrication, I showed you that big CA20 module where you could see its sub-assembly from the different component parts. We learnt a lot of lessons doing that the first time around. And it's simple stuff, but it's stuff that you only learn by doing it. Which fastening do you make first? Which bit of alignment do you do first? That makes it then easier to put all of those pieces together without finding, in typical sort of IKEA style, that you've got a piece left over at the end. I sometimes use that as that sort of IKEA analogy when we talk about these standard plans, because anybody who's been foolish enough to be tricked into buying 4 of the same, bedside table or wardrobe or whatever and made them at home, that when you've done the first one, you get it done and you think, well, next time around I could do that a whole lot better. And the second, third and fourth always end up looking a much better job, and they get done quicker because you know what to do. You've got the instructions there and you follow the instructions, but you actually only really learn by doing. And although it sounds like a trivial example, the same is true when you're building a nuclear power plant. The instruction book's probably a bit thicker and it might not be in quite so many languages, but you still really learn it by doing it. It's practical things. As I say, which order do we put things together? What's the best way of ensuring alignment? What's the best order to put the fastenings together to make sure that we do the assembly properly, that it doesn't leave you with a problem later? And some of those things that you do and then undo and then redo on the first one, you do first time on the second, third and fourth. So the containment vessel bottom head that I talked about is a classic example. That was the thing that left us 6 months delayed on the first unit because making those components, bending them to shape and then welding them to very tight tolerances was very difficult. And the first time around we tried to do it in a module facility that was outdoors, and we hadn't taken account of the impact that the humidity and the temperature variation would have on that very challenging activity. So the second time around, and for the future builds, we do it in a fully enclosed facility. And we've managed to do it per the original schedule without the difficulties that we hit first time. And all of that learning is absolutely vitally important. And by having it on a standardised plant, it means you can take the benefit of that learning for future plants in China, for future plants in the US, for future plants in Wales, Cumbria, Gloucestershire, wherever it might be. So I think I mentioned earlier the projects are on schedule. If I didn't, then I'll say it again now. Some of the benefits and some of the things that have helped contribute to that, the long lead times ordered early, long lead materials ordered early. Again, it's Greg said the importance of planning in all of this, not just of the planning process, but planning as a part of project delivery can't be overstated. So dealing with the suppliers, getting the suppliers ready, putting the contracts in place to deliver the key items and getting those procured on time or get them there a little bit early, so there is some contingency in that to help the overall programme. I won't go through all of these, but you can see some of the benefits in terms of things like concrete pour times, the manufacturing of heavy components. So many suppliers involved in all of that, but keeping all of them on schedule is key. We've made excellent progress on learning how to put those modules together and learning how to do that containment vessel fabrication. And that benefit, as I've probably stressed enough times now, but being learned and gained and captured and will deliver benefits many times over. I don't think we've had the numbers so far in the presentation, so I'll throw them in now since I've got a couple of minutes. But if you compare and contrast the UK's historic nuclear programme with France, the UK, by my calculation, 19 nuclear power stations and 15 different designs, and certainly some of the technical guys and ladies in the audience will tell me at least 19 different designs, but some of them are at least cousins, if not siblings. 19 stations, 15 designs. Pretty much everything we built has been first of a kind or very close to it. France, 58 stations, 3 designs. The temptation after you've built 15 plants or 20 plants the same to improve it because you know what you could do better next time and the technology's evolved and the experience has accumulated is colossal. But the benefit of going beyond that and building standard plants time and time and time again, you only need to look across the channel to see what that's delivered. A country that's got some of that would probably the highest proportion of its electricity from nuclear anywhere in the world, and a country that's got some of the cheapest electricity prices in Europe and reliable low carbon electricity for its people. It's a great example. And they did the exact opposite of what we did in the UK, which was always succumb to temptation and say we can make it a bit better, we can do it a bit different. We learnt this last time, let's change it. Learning isn't about changing it in terms of changing the design as you go forward, it's changing the delivery and improving the delivery. And to use that analogy again, you want the same wardrobe, but you want it built in half the time with fewer blisters on the hands. So, what are we doing around the world? Well, we're building on that success from China. And you can see here, this is our contracted order book. So these are plants that we have under a contract with the customer signed up at the moment. 4 in China, and as I've already said, we don't expect that Chinese program to stop in 2015. We're already in active discussions about the ones that will follow that. 6 in the US that will come on the heels of that China program. So the first US plant, where already they've done huge amounts of that site preparation at risk because the approvals to proceed are not all in place yet. But the first one's due to come on stream in 2016. Our target date for an AP1000 in the UK, if we're successful with Horizon Nuclear Power, 2020. So by the time we get to build the first one in the UK, hopefully in North Wales, hopefully in 2020, we'll have 9 of these at least operating around the world from which we can gather that experience and treading in well-trodden, well-established footsteps. And it's not just having the design schedule, it's bringing that experience and that knowledge and that know-how from unit to unit and from country to country. So I mentioned right at the start of the presentation that we're working with the Shaw Group as our construction partners in China. In the US, where we're also delivering the turbines as well as the nuclear island, we're working with Shaw and with Toshiba, 2 of our Westinghouse's parent companies. And when we come to the UK, as part of our delivery team here, Nuclear Power Delivery UK, Westinghouse, Shaw, Toshiba, and Lango Rourke. Big UK-based construction company, very well experienced in dealing with highly complex, highly challenging projects, not least the London Olympics, which they're one of the key partners in delivering, teaming with us to deliver the AP1000 units here and making sure that we bring all of that knowledge and experience from all of those other projects in people's heads as well as on emails and spreadsheets and so forth, but bringing that hands-on experience of people who've worked on AP1000 projects in other countries. Absolutely crucial.